This is a lecture on drag and drop programming for Comp 360 programming languages at North Carolina A&T State University. Hey, this ain't Haskell. And now for something completely different. This is not even in the textbook. A lot of students, when they start programming, get intimidated by the syntax of most programming languages. Java, C++, even Python have exact syntax, and it's easy to make lots of mistakes if you don't watch what you're doing. Drag and drop programming or visual programming attempts to avoid this problem. Programmers don't have to type the program, they drag and drop program items or program elements into the program. Hence, you never have a syntax error. There are a number of drag and drop languages. Scratch was the original. Snap and Build Your Own Blocks, BYOB, is another one. Alice is a drag and drop language that we used once at A&T to teach object-oriented programming. The MIT App Inventor is a drag and drop programming language to build Android apps. And there's also Hopscotch and Gamefruit, which are two other drag and drop languages. Scratch was the first one, developed around 2005 by Michael Resnick at the MIT Media Lab, the lifelong kindergarten group. It's intended primarily for young programmers, trying to get people started with programming. It runs online through a browser, so to use it, you do not even have to load any software on your computer. Their Scratch online community has a slogan, Imagine, Program, Share. They like you to develop things and then share them with your friends. It's been quite popular, particularly in the school systems. One, it's free, and you can access it through the browser, so they don't have to install software, which the IT folks in most school systems don't want to do anything like that. It's got a lot of use. It's also now spread to more than 150 different countries and available in more than 40 different languages. Scratch has a large collection of objects that you can move into the program to perform different events. They're grouped in different categories. The motion ones moves objects on the screen. You can change their visual appearance, you can have sounds. Event category allows the objects to respond to events, to mouse clicks or other input. And there's the usual if, then, else looping things and other operators. So give it a try. Right now, go to scratch.mit.edu and write a program. Try writing a program that moves the creature, the little animal that's in the middle, in a square that's 50 units on a side. So have move 50 units, turn a corner, move 50 units until it comes back to its original position. So stop the video now, go to scratch.mit.edu and give it a shot. I'll wait for you. Did you really do the problem? You learn by doing. Here's a possible solution for having the creature move in a square. There are, again, multiple ways to do it because there are always multiple ways to do it in almost any programming situation. In this example here, I have the creature move 50 steps with the move thing, which is blue, and then have them turn 90 degrees. That, of course, is required to do these. Then had them wait. Now the wait is optional. You don't have to have the wait, but if you don't put the wait in there, it all goes blink and appears as if nothing has happened. So I put a 1 second wait in after they move every length. And then I repeated the whole thing 4 times to make them go around 4 times. Now you could have just, of course, put the move, turn, move, turn, move, turn in there 4 times, and that would have worked. But better programming technique is to use a loop. Another drag and drop programming language is Alice. Alice creates a animated world where you can drag objects and then write programs that animate the objects. Uh, this can also be downloaded for free from www.alice.org. Oh, and why Alice? Well, because the Alice in Wonderland creature is no longer under copyright, and Alice comes first in an alphabetical listing. There are different kinds of animations you can make with Alice. You can make a movie, and in fact, Alice provides the ability for you to create an MPEG file with a movie of the motion and sounds of the creatures. And then you can do interactive events. In other words, you can, when you click a mouse or use a key on the keyboard, the creature can move for you or do other events. In Alice, you start by creating a world. And there's several worlds to pick from. The grass, which is I think the default. You can see green grass and blue sky. And so it's always blue sky, except for the space one, which looks something like the moon, and you've got a gray moon surface and a black sky. So you pick one of the worlds from the templates. Of course, you always create your own, but these are available. And then once you have your world, you can then select creatures from the library of creatures. As you can see, we have bugs, dinosaurs, and birds, and then just drag the bird and move it into the proper position in your world. Of course, all sorts of techniques and tools you can use. You can position the object with the mouse. You can move it left, right, up, down with the mouse. You can change the point of view of the camera, which can be initial point of view, and also you can move the point of view during the execution of the program. That is, the point of view is where are you looking at the object from? You can move up, down, relationship to where the other objects are. You can make things bigger, smaller, and move them in relationship to other objects. An object, in the object-oriented sense, is anything that appears on the screen that's that can be identified from some other object. Objects can be made of smaller objects, and so an object not only has appearance on the screen, but you can has attributes. In other words, class instance values, and you can have methods associated with it. So it's very object-oriented, and in this case, the objects are visible. So you can move an object in the screen and then change its properties, its attributes, class instance variables, and use methods or write new methods that cause it to take out certain actions. As I mentioned, objects can be composed of parts. In this example, the bird has a body, a right leg, and a left leg. And so all parts of the bird can take individual actions. It's a three-dimensional world. Objects can move up, down, left, right, forward, back, and they can rotate. They can rotate in any one of the standard 6 degrees of freedom, rotate on all 3 axes, so they can get in any orientation. And they can move in any one of these shapes during the animation. Often the sub parts of them, the legs, the arms, can also move in many different directions. And you have classes of objects, and you can make instance of the class. So we have an object called person, and you can make instances of that class person. Or in the example here, we also have the class dog, and you can make instances of the class dog. Of course, all objects of the same class all have the same attributes and the same methods. Alice is object-oriented. It has inheritance, abstraction, encapsulation, and polymorphism. Here's a Alice program, and as you can see, it's very similar to Scratch. It has the big C's that can be used to repeat things. In Alice, there's one you don't see in other languages. It's do together. And do together means do all the actions inside this block at the same time. You'll notice that inside the do together, there's do in order. So there's the snowman head left eye moves up and then it moves down. That's in a sequential order. And then the right eye does the same thing. But those both happen together. So we have the do together block. And they have this typical ones that Scratch has, repeat, if, then, else, reaction to events. There's a large number of built-in functions that you can act on various objects. It's a polymorphism thing where most actions can be played upon most objects. Different type of drag and drop language is the MIT App Inventor. As you can see here, the creators said it was an innovative beginner's introduction to programming and app creation that transforms the complex language of text-based coding into visual drag and drop building blocks. The whole concept was that it was relatively difficult to build an app. If you've used the Android Studio to build an app with Java, it's not always easy. And they wanted to create something that was easier so almost anybody can make an app for their phone. It was originally created by Google back in 2010, and then they gave it to MIT, which polished it up and released it to the public 2 years later. It was available on the start of the Hour of Code in 2013. It, like Scratch, works online. In other words, you go to the website and in your browser you develop the program, dragging and dropping boxes into the program. It's, again, purpose of this is to develop Android apps. And you can load your app that you create with the MIT App Inventor onto an Android phone or tablet. And there are, I think, 3 different ways to do this, one of which is via Wi-Fi, which seems to be the best way. So you have your phone sitting next to you connected to the Wi-Fi, and your computer, which may or may not be connected to the Wi-Fi, but can get there somehow. And you can scan a Q code and it will download your program onto your phone and run it there. And it works quite well and very quickly. So as you develop your app and you want to run it, you press the run button and it appears in your phone and runs. Now, if you don't have an Android phone, there's an emulator available and you can test your programs in the emulator. By the way, if you've ever used Android Studio, the emulator in MIT App Inventor is a whole lot easier to use than the emulator in Android Studio. The App Inventor has the usual activities that you'll find in a drag and drop language. It also has the ability to access the phone type things that you don't see in most computers. Here's a list of some of the sensor connections that you can use in Android Studio. The accelerometer, that tells if your phone has been moving. You can see clock is nice. Location sensor, yes, most phones have a GPS location. You can find out where you are, and all sorts of other sensors that your phone may or may not have. I didn't know my phone had a magnetic field sensor. Not every phone has every sensor. So there is an assignment posted on Blackboard. You have to create an Android app using the MIT App Inventor. You must use the MIT App Inventor because this is a programming languages class and we want to have the experience of using a drag and drop language. The assignment has about 12.5 different possible programs that you can write in MIT App Inventor. You can select one of those or make up your own, but whatever selection you pick, one that's listed or one of yours, it must be approved by your instructor before noon Tuesday, April 14th. So send them an email, tell them which one you want to do. Obviously, everybody is not going to be allowed to do the same app. And then you have to have your app written by Friday, April 17th. and upload it to Blackboard by midnight. Upload the source code form. It's the .aia file. Don't upload the APK. The APK is the form of the application that you can load onto an Android phone. We don't want that. We want the source code so that the TA can then load your source code into the MIT App Inventor and look at your program and see how it works. To get started, there's many ways you can look at the MIT App Inventor website, but since you are a computer science person, you might want to start looking in the library. Hey, Dr. Williams didn't tell us how to write App Inventor programs. You're computer science students. You can figure it out.